Hello guys, I want to welcome you back to Engineering Trends and Innovation, where we explore the cutting edge of engineering and technologies that are shaping our future. So I am your host, Alimami Conte, and in today's episode, we are literally having a guest that we are going to talk about the future of with fiber optics and also what's its relation towards his with the personal research. So I want you to stay focused, grab a pen, grab a paper or a book, and then as we dive more into the non-technical and also the technical points of this episode, I want to basically welcome you into the podcast of Engineering Trends and Innovation. This is a podcast where we share knowledge, we share understanding, we inspire the younger generation, and also we create a pathway for others to learn and grow in the field of science, with technology, engineering, and with mathematics. We encompasses all of this in a way to build a community where we can all learn, grow, and build a sustainable and more efficient and just society. So please, I want you to introduce yourself to my audience, and then let us pick it up from there.
Hi everyone, I'm happy to be here. My friend Alimi Conte, I've known him for some years now. I've seen the transformation. I'm glad and happy for what you're doing, especially the focus on, bridging the gap and also to young generations. Let me start by introducing myself. My name is Chinoso Ezobi. I'm originally from Nigeria. I had my bachelor's in electrical engineering. After that, I went into industry. I worked in telecommunication industry for about 15 years.
Okay.
I traveled to Finland, had a master's degree in telecommunication engineering, got back to Nigeria, did another 4 years, then came to the United States and started my PhD program in electrical engineering.
Okay.
So I'm currently a PhD candidate. I'm hoping to graduate by end of the year.
Okay, that's good.
So I'm working on my research at the moment.
That is really good.
So
That is really, really good, and it is such inspiring journey. So, this one drives me to a question where I would like to ask is that what sparked your interest in telecommunication and fiber optics? So maybe be specific.
okay, so I will say, let me start by saying that it was engineering that sparked my interest
Okay.
before telecommunication. Because, for example, I said I was originally from Nigeria. By the time I was going to do engineering, at that time, telecommunication wasn't a job that is well known. As of that time, there was nothing like GSM, there was nothing like all the mobile telecommunication we know as we know it today. So first, I had interest in engineering, and my simple reasoning was I love science. I also love mathematics. But in the science aspect, I didn't too much, like biology.
Okay.
So originally, my interest was to go into pharmacy. But because I don't like biology, I tend to do what else can I do that will be mathematics oriented. Once I study maths once, I know it. It registers in my brain. I hate to read voluminous books like biology,
biology. Yeah.
Exactly. So that was what drove me into engineering. But originally, when I finished my high school, or secondary school as we call it back in Africa, the next thing was to go in and do pharmacy.
Okay.
But when I discovered that I'm going to be dealing with a lot of biology in pharmacy, I said, what is the next best thing? And that was how I decided that electrical engineering would be a good thing for me. So when I ventured into electrical engineering, by the time I was graduating, then the GSM came into Nigeria. There was a massive lot of activities
Okay.
happening in telecommunication. As of that time, the as of the time I graduated in 2001, the GSM started in Nigeria in 1999. So it was at the right time.
At the right time.
Yeah, exactly.
Yeah.
So when I graduated, I even at that, I don't think I really have like much interest in exactly what I wanted to do. But there is this 1 year program after graduation in Nigeria we call National Youth Service.
National Youth Service Program, yeah.
Exactly.
The
So
NSY.
exactly.
NYSC.
So I was very lucky in the so for National Youth Service Corps, you go and do like 3 weeks, I think 3 weeks in a camp where you wake up in a camp, and so in that camp I play soccer or football as we call it in Africa. So that gave me an edge. They now asked me, where do you want to do your primary assignment? Primary assignment is like where you want to do
Do your
internship.
internship or wise, okay.
Yeah, so I was given opportunity to choose wherever I want to do. So I chose telecommunication at that time. I chose to do it with the national career at that time.
Okay.
We call it NITA, Nigerian Telecommunication.
Okay, Nigeria Telecommunication
So
Authority.
the moment I entered, I was hooked. When I saw the massive, the things that goes behind you making a call,
Behind you making a call.
I said, no, this is like well built for me. And that was what sparked my interest.
Okay.
After that, I started, looking for a job in telecommunication, and that's how my interest now in telecommunication kind of evolved.
That is like I think at some point you mentioned that you did not like body biology, right?
Yeah.
I can recall I have the same experience back home. I went to the Prince of Wales, which is our the secondary schools, which is outrightly called high school out here. And I was the only student at that at that specific year that doesn't take the biology at the WASC exam, the West African senior secondary school exams. I was the only student that did not take biology at that point.
I took mine and I passed it very well. I can't remember exactly what I, but I know I passed it very well. But the point is, I know I struggle. So I'm not a kind of person that will concentrate for a long time reading. So mathematics is very easy to me. Once you read, you understand the formula, then you move ahead.
And then you move
But
ahead.
just to sit down and read biology and read, that's what, it's not as if I'm not going to pass biology, but of course, in scale of things,
Yes.
mathematics comes like higher,
Yeah.
and it makes it easy for me.
Yeah.
Yeah, my concentration level, I can't concentrate for a longer time reading. So maths is a little bit easier for me to deal with, and physics and all those kind of things that has
kind of
like
thing.
some aspects
Okay.
of math. So yeah, I did. I also I hate biology, but at least I took it.
Yeah, definitely, definitely. So that's one will have to move me to the second point that I was thinking about. Like for my listeners, they might be asking, what is fiber optics? Like basically they want to know what is fiber optic. They have been hearing this term fiber optic. Can you please explain to them for me?
So fiber optics is a cable. It comes in a form of glass. The simplest way to explain it is, if you see a fiber optic, you might not be able to see the glass inside because there is always a protective cover outside.
Yeah.
So the protective cover helps to preserve it. Because it's a glass, if you don't preserve it, it might break.
Yeah.
So it's used virtually everywhere.
Okay.
And it is, as of today, the best form of communication. There is others. There is one that is called microwave.
Microwave, yes.
So microwave is good. It's faster to deploy.
Okay.
But the challenge with it is it's affected by weather, and also it has a line of sight issues.
Oh, okay.
So when I say line of sight means for the two microwaves to work together, if you drive out and see all these telecom towers, you see
Yes.
something that's round.
Yes, definitely.
So it kind of, what is on point A must speak to something that is point B. But the challenge is that there must not be anything in between.
Yes, yeah, any blockage.
Exactly, any blockage. So we call it line of sight. So there must be a line of sight for you to communicate. But fiber optic is different. It's a cable. But the good thing about it is it's not affected by weather. It is not affected by noise. The only challenge you might have with it is it usually takes a longer time to deploy, because most communities, most countries, what they do is either you lay it on a power cable,
Okay.
or you have to dig from point A to point B to lay it underground. So in developed countries, what they do is that when they're building their roads,
Yep.
you see them in certain like PVCs.
Yes, PVC is for that.
So they call it cable ducts.
Yeah, okay.
So already in developed countries,
Yep.
they already have these cable ducts. So all you need to do is that if you want to deploy fiber optics, you just come and use those cable ducts to deploy it. It's easier.
Yes.
But in the developing countries, they don't consider all those things. So in developing countries, you have to see, that's why you see, I don't know if you are familiar with it, but in most developing countries, you see them digging from point A to point
Point
B,
B, yes.
destroying
Definitely.
roads and everything. It's
Yeah.
because when they were building the roads, there was no provision for
Yes.
those kind of things.
Yes.
So basically, to answer your question, I know I've been jumping up and down.
Yep.
Fiber optics is a cable that transmits information from point A to point B in form of light.
Okay, in the form of a light.
In form of light.
Okay.
So the only difference is that at both ends, let's say from point A to point B, at point A, you have a device that can convert light energy, electrical energy into light energy.
Yep.
Then it enters fiber optics. When it gets to point B, then you have the same kind of device that will convert from light back to electrical energy, so that you can now interpret it. You see it in form of data, you see it in form of internet, you see it in forms of making calls.
Okay.
So fiber optic is basically a cable that is laid from point A to point B in order to have communication. The only thing is that it's not really visible to end customers.
Any customers? Okay.
Yeah, so most times it's service providers, like mobile service providers. In this country, we might call it AT&T, for example,
Yes.
or Verizon and all this.
Verizon
They are
and
responsible for
yes.
laying. They are responsible
Comcast,
for maintaining the fiber optic cable. So it's not really interfaced with maybe end customer, except maybe in this kind of buildings where internet service providers, they bring fiber optic cable to maybe this kind of residents.
Residents, yeah.
Then they will now use it to distribute internet.
Distribute internet, okay.
So they call it point of presence. So it means that your service provider, whoever is your internet service provider, has a point of presence here.
Yes.
So from that point of presence, they will now distribute to all the apartments, all the buildings around this axis.
Yeah.
So it's not really responsibility of the customers, like end users, to know exactly what is happening with fiber optic cable. But like I said, it's the best as of today.
The best and reliable way
of communication. It doesn't have interference.
Yeah.
It doesn't have. It's not affected by weather. We talked about microwave earlier.
Microwave, yeah.
Microwave is affected, like when it wants to rain. It affects the line of sight. The air becomes dense. Then it kind of attenuates the signal.
Yeah. Okay. I think if I also share about my little experience, I work as an intern for a telecommunication company out here in Wamibo, the US, where I serve as a coverage test engineer. I was basically deployed in Richmond, Virginia, where we worked on various fiber optic systems. So like I actually understand that it is the most reliable way of communication, and also it supports larger bandwidth of communication. So that one leads me to my question on what are the challenges that we face when we are deploying fiber optics. Let's say we are deploying fiber optic to improve our way of communication, but there are a little or 1-2 challenges that we face. So what are some of the biggest engineering challenges that we face in deploying and maintaining fiber optics systems?
So the biggest challenge that you face is first the cost.
The cost.
The cost. And also for a developing countries,
Yep.
or let's say in a new area, is the time to deployment.
Yep.
Because, you know, I mentioned to you that you have to dig from point A to B.
Yes, from point A to point B.
So it takes time to do that. Yeah, I know you have like tools that you can use to do that.
Yep.
But even if you, after digging, with a tool, you have to also slot in the PVCs.
The PVCs, yes.
Because you don't dig and close, those fiber optics needs to be maintained. So you have to install it in such a way that if there is any issue in future, you can pull it out. Or if you need additional cables to expand, you might be able to do that. So there has to be a cable duct. So first is expensive. First deployment is expensive, but over time, the expenses levels out.
Okay.
But first deployment is the first engineering challenges is the expenses. Then the second thing is those deployment like digging.
Yep.
Some areas you might need to get permit to be able to dig.
Yep.
Sometimes it might involve trying to cut a walking roads. So those things you need to get a permit to be able to do that. So all those things contribute to the challenges that that engineers face. Then other things, it's also affected by probably natural disaster. Just imagine where there's a natural disaster and there's maybe a road cut or something or flooding that cuts the road and all those things. It cuts the cable and rest of them. So, yeah, but those are the challenges I can think of, the cost, and also for the providers.
Yep.
The end user equipment. So let me go back a little and stress what fiber optics is like. The main road. The capacity of the main road, you might have like 4 or 5 lanes.
Yeah, 4 or 5 lanes, yes.
Yeah, but it does not mean at every point in time you have vehicles in all those lanes.
Yes.
Sometimes there'll be traffic.
Yep, definitely.
Meaning that in the same thing with fiber optics. So, like on Sundays, the roads are relatively free because people do not get to work. But in communication, it's almost the opposite. Because people stay at home on Sundays.
On the weekend.
On weekends,
Yeah.
there are likelihood of making more calls, using more internet,
Yes.
and doing some other things that will require larger bandwidth.
Larger bandwidth, yeah.
Yes. So one of the challenges you face is the end-to-end equipment. So depending on the capacity of the fiber. So let me say that fiber optics is limitless. The capacity is limitless. It's only limited by
the end-to-end equipment. Okay.
So, and end-to-end equipment also comes with cost.
Yes.
So it depends on what the service providers are able to afford. So if they're able to afford an equipment that has a very large capacity, then that will define. In fact, those equipment define the capacity of the fiber cables. That's the beauty of it. So those are the challenges. The end equipment, not end user equipment.
The end one, maybe.
The deployment challenges. Like I said, I have been involved in where fiber optics were in a complex, like in a power line.
Yeah.
You know how they lay the cable?
Yes.
They use a helicopter.
Yes, they use helicopter.
So sometimes you also have some casualties.
Wow.
Yeah. So those are the challenges. Especially for high tension.
High tension cables. Yes, definitely.
Yeah, those are like very dangerous. It has cost lives.
So I have an experience of maybe working on fiber optics, maybe the platforms, but but my uncle actually is with the telecommunication engineer, but back home in Sierra Leone. He used to take me to some of these telecommunication spots where maybe they have their telecommunication towers. most of the work that we do is to repair the cables.
Oh, okay.
But because we know that rats eat some of what I mean with the cables,
Yeah. So
like
yeah. So the technical term for it is splicing.
splicing,
Yes.
definitely,
Yeah.
definitely.
So
But we do splicing a lot.
yes. So that's the technical term for it. So what happens is, so every cable, every telecommunication has a range.
Yes.
For example, the network cable or LAN cable, as you used to call it,
Yep.
the maximum you can travel is 100 meters.
Yep.
After 100 meters, it's not as if you can still not support data, but the data begin to attenuate.
Yes.
Microwave can go 60 kilometers.
Okay.
After 60 kilometers, so it's believed by Fresnel zone that after 60 kilometers, you will not have line of sight. But in reality, you cannot do 60-kilometer microwave.
Yes,
If you do 60-kilometer microwave, it can never be usable because even in a flat terrain,
Yeah.
if there is any small weather changes, it will attenuate your signal.
Okay.
So normally, the rule of thumb is maybe do like 20, 30 kilometers, to make sure that your signal remains strong when there is issue. So, but for fiber optics can go 120 kilometers without repeater. So it's after 120 kilometers that you can now put a repeater.
Yes.
Or you splice it to boost. So repeater for the benefit of our viewers are
Yes.
something that repeats the signal, because when signal travels from point A to point B,
Yep.
there's every tendency that after some time it will become attenuated.
Yep.
So in telecommunication, in fiber optics, for example, we use repeater to boost back this signal. So that's what is called a repeater or a generator or whatever. So it travels 120 kilometers before it can be regenerated. So back to what we are saying.
Yeah.
So splicing
Splicing.
is actually what is used to join or connect fiber optic cable, because like I said, after 120, of course, most times you can't even have fiber optics that is that long. So along the line, you have to be joining them.
Yep.
In technical terms, splicing. So the ability to join one or two cables is, when you want to join, you cut it, remove those cores like I told you, and because it's a glass, you need a special equipment called splicing machine to be able to join those splices together. And the good thing about some of these machines is that when you join them, it will give you a result of the attenuation at that joint.
Definitely. And I can actually recall that me and my uncle, we actually did a lot of that. We did a lot of splicing. And it was at some point that with the company that he was contracting for, they call us every weekend, but because they face that, but because most of their towers were in the rural areas, and but they are exposed to rats, they are exposed to other things that makes it but the difficult 1 or 2 weeks, but there is but the shortage in terms of their communications. So like they call us in. So now let us focus on your research on non-linear optics. So basically, I want to ask your research focuses on using lasers to characterize semiconductors materials.
Yes.
Through non-linear optics. Can you explain what non-linear optics is and what is important for future technologies?
Okay, so I think the best approach would be, for the benefit of our listeners, is to understand what a nonlinear and linear relationships are. So, for example, if I increase, how do I put it now? If we have two variables, A and B. If I increase A and B increase or decrease with the same amount, it's a linear relationship. Do you get my point?
Yes.
So, but there are some other relationships if you have two variables, that if you increase A, it does not mean that B will increase or decrease linearly. So those are called nonlinear relationships. So now bring that into my research. So I look at the materials I look at, they have linear properties. But basically, my research is to look at the nonlinear part of it. Do you get it? So, and one of the things that is interesting about nonlinear properties is sometimes it's very difficult to characterize, but there are important parameters that are used to determine the application of materials.
Okay.
So basically, back to my research, I look at nonlinear properties like nonlinear absorption
Okay.
and nonlinear refraction or refractive index. Most materials have linear refractive index. And how do we explain a refractive index to a customer? Is amount, how do I don't really know how to make it easy for,
bring it down.
yeah, for a
Down
customer.
for me with the layman.
Yeah. Okay. Refraction. Okay. When we are talking about refraction, it has to do with light.
Yes.
Yeah.
Definitely.
So maybe let me stay a bit back. So materials.
Yep.
Any material can do three things
Yep.
when a light is shining on them. You can reflect light.
Mm-hmm.
You can refract, meaning that the light can bend.
Yep.
So reflection means that the light returns. It hits you and returns. And returns maybe towards the light or away from the light.
Yep.
You can absorb the light.
Mm-hmm.
Then some material can absorb some, reflect some. So but the three basic things is that refraction, refraction, and absorption.
And absorption. Yep.
Yes. So I use laser systems
Okay.
to look at nonlinear refractions, look at nonlinear absorptions.
Mm-hmm.
So basically what we have done is that we set up a system, purely light.
Yep.
The light source is laser. We set it up in such a way that it travels through a straight line.
Mm-hmm.
Then we put our material, whatever we want to characterize, we put it along the pathways and focus the laser light on it. So when you focus the laser light on it, so basically my research is limited to materials that can transmit light. Although the same technique I use, there is also people that, if you tweak it a bit, you can do what is called reflective characterization. So basically my method is called Z-scan method. So, but there are some people also that works on reflective Z-scan. These are reflective surfaces are the surfaces that instead of allowing the light to transmit, they will reflect it back.
They will bounce it back.
Yeah, they'll bounce. Yeah, that bouncing back might be the correct word.
Yes.
Yeah. So, but basically my research is on materials that can totally transmit light. So once this light goes through this material, and I have a detector that looks, so the light leaves the material and enters into a detector. This detector we now use computer to record their response to such light. So we have a automatic stage that moves these materials I want to characterize in and out of the focus of the laser.
The laser.
So that way, we collect it. We have a mathematical model that we use to characterize it. We now extract the nonlinear refractive index and nonlinear absorption. Why is this very important? For example, let me give you the simplest example so that you understand why this is very important.
Yep.
You are using a reading glass.
Yes.
A reading glass, for example, you need materials that can transmit light.
Definitely. But between one with the lenses.
Yeah, exactly. So, but just think about the sunshades. The sunshade, you don't need things that can transmit light because you need the sunshade to protect.
Yes, you.
So you need
excess light.
Yeah, you need materials that can reflect, total reflection. Do you get it now?
Yes, I get it.
So those are just the typical examples. So apart from the semiconductor materials, I also look at fiber optics. You know, I told you fiber optics are glasses.
Yes, are glasses. Yes, definitely.
Yeah, so one of the objectives of my research is, of course, the current cable, you know, we talked about fiber optics before. The current fiber optics that is used are made of silica materials. Silica. materials. For those that are very familiar with periodic table.
Periodic tables,
Yeah,
yes.
but if you are not,
with silicon. And,
yeah, exactly.
yeah.
So, but there's a set of new materials, new fiber optic cable that are a combination of rare earths. They call it transition metals. So I look at a fiber called zebron fiber. So each of those letters, Z, B, L, A, N, is made of different elements in the
periodic table. Okay.
So the initial, so first of all, it was discovered by accident, as like most of the useful things in
yes,
life.
definitely.
So someone in France, while he was trying to do it like a combination of things, he accidentally mixed some things and discovered that this thing looks good. So initially, it has a better performance than silica fiber. So the original intention after he discovered it was that this is going to replace silica for telecommunication purposes.
Telecommunication purpose, okay.
I did not mention that fiber optics is almost used everywhere, not only in telecommunication. You understand? It's used in even in some of the
defense,
medical equipment,
medicine, yep.
even in some airplanes.
Yes.
So where you have
transportations as well.
yeah, so where you want to have like communications that is, you want to be like 100% guaranteed.
Reliable communication.
Yeah. If you check very well.
Yep.
Then there is every likelihood that fiber optics is involved,
yes,
because it ensures that you have a maximum communication
with that.
Yes.
Okay. So that one also moves me to maybe the point is that since you have give in-depth, like what is the exciting emerging application of nonlinear optics that you think people should pay attention to? Like based upon your research, what do you think are some of these emerging applications where we are applying?
So yeah, you ask a very nice question.
Yep.
The nonlinear optics aspect of it, people might not, end users, just like fiber optics,
yes,
might not be able to see it. But what it does is that it helps in discoveries. It helps in determining materials.
Yep.
There is a whole lot that is ongoing. For example, when you go to hospitals,
yep,
some of those medical devices you use, those medical equipments,
yep,
they are a product of nonlinear optics.
Nonlinear optics.
For example, when you go to hospitals and they put that clip that checks your oxygen level.
Oxygen, yes, definitely.
Do you know how that thing is light?
Yes.
So the light, reads some materials and transmits it. So those are some of the ways they use nonlinear optics. So you might not see it as in its application, but most nonlinear optic application and research are actually done on background to discover new materials.
Okay.
Like, there are some people that work on human brain interfaces.
Yes, human brain
interface. MRI, data, and all those kind of things. So there's some components of nonlinear optics on it. Your iPhone or phone you use,
yes,
some of the things, like the camera.
Yep. Yes, basically it captures light.
Yes.
The main purpose of our camera is that it captures light.
Exactly.
And now the software now transform this light into images.
Yeah, so there is a whole lot that is ongoing that, you pick up these devices, you don't know.
We don't know
what
technology
exactly
behind it.
So if I tell you, for example, for iPhone, for example, I can at least name 5 or 6 people or 6 researchers that have worked on it. Somebody determined the strength of the glass cover you are using.
Yes.
Somebody determined, for example, the chips, the size of the chip, the number of resistors and all those things that has to be put into that place.
Yeah.
Somebody determined the heat level.
Yes.
That it can tolerate. Somebody determined the noise level. how sensitive it needs to be.
Yes.
Somebody determine the depth or the width of the aperture of the lens
Lenses.
of the
Yeah.
camera.
Cameras. Yeah.
So you can see somebody determine the size,
Yes. The size of it, the weight.
the weight. It's not one person that does all these things.
Yeah.
So
it is a collaboration.
a collaboration of things that now bring them together. So that's one of the things I find very exciting in research, and I'm at a very good advantageous position because I've been in the industry.
Yes.
And then I'm in the research, and those two are just coming together. For me, it's like an eye opener. Maybe some other time. I don't know whether I have time to talk about it. Why the switch from
Industries
to
to
research.
to help me with the research.
Yeah.
Yes.
So, but those are the things.
Okay.
Yeah.
That is good. That is really, really good. So if we are thinking about the future with the career insights, let's say we are looking ahead, how do you see fiber optics and nonlinear optics evolving in the next decade?
Fiber optics is not going anywhere, at least for now. There's no alternative to it for now.
Yes, that is the thing.
Yeah. There's no alternative for now. And to tell you the truth, its usefulness is not even yet fully explored. Over here in America, they are talking about fiber to home.
Yeah, fiber to home.
Fiber to home simply means, for purpose of our viewers, simply means, fibers are installed in homes.
Yep.
But in places where we come from,
Yep.
what the level they are at the moment is fiber to site.
Yes.
So the difference is here, almost every home is very close to fiber point of presence.
Yes, which is where the
Yes.
with the cable line.
So, but in Africa or in developing world, they are currently implementing fiber to site, meaning that the telecommunication or service providers are still providing fiber optics from their offices to the cell sites. In those developing countries, there's still a need for fiber to home, because that's the way to go. For example, if you want to do streaming, for example, you can do it with microwave.
Yes,
If
with
your
Wi-Fi.
yeah. So
Definitely.
if your business depends on it, you can't afford not to do it with fiber.
Yes.
Because fiber is not affected by weather.
Yes.
If you are doing it with all these hotspot and microwaves,
Yes.
it means that when it's about to rain or when there's a heavy rain,
There's a drop in the signal strength.
so it affects your business. In medicine,
But you can't use the microwave at the front line of doing operations.
yeah, exactly. So this one they are talking about remote surgery.
Surgery,
you cannot do it. So
application.
fiber is essential to some of these things.
Okay.
So communication is going to get better. Driverless cars.
Yes.
You can't afford to have latency. For the benefit of our users, latency is a delay
Yes.
in communication. So in communication terms, they call it latency. So sometimes, or buffering. You want to download something on the internet, you see those things that go round.
Yes, yes.
Those are latencies or buffering. In driverless car, for example, you can't afford that. Just imagine you are on a traffic light.
Yes.
And you lose communication from your vehicle to maybe the station that it connects for the signal.
Yes.
You can't afford to have a minute.
Definitely.
A minute can be dangerous.
Yes.
Do you get it now?
Yes.
So as we move ahead with AI, as we move ahead with technology, fiber optics becomes better part of our life. Now we're talking about smart homes.
Smart homes, yeah.
You cannot do
definitely.
smart home with any other form of cable apart from fiber optics.
Yes, definitely. I think my last episode where I talk about smart homes
Yes.
in terms of HVAC
Yes.
application, where now we are using our phone to control the indoor temperature
Yes.
of our homes. So
Yes.
you need a strong
Yes.
communication
Yes.
signal that helps you to communicate at a wide distance with such click and go action.
Yeah, so the only thing I will leave our viewers with is whenever you hear smart, know there is a communication behind it.
Communication behind it, yeah.
There can never be any smart without any communication.
Sure.
So if there is a smart and there is communication, then there is fiber optics involved. Because you cannot use any other form of communication. As of now, there's some other form of communication like Bluetooth.
Yes.
But the Bluetooth is
like Bluetooth,
distance
infrared,
limited.
yeah.
Infrared and all those
Yes.
things. They are infrared. I think uses a line of sight.
Yes.
That's why you are removed. For example,
Yes.
if something blocks your remote,
blocks it.
yeah,
definitely. I think discussing these topics gives us not only the technical understanding but our day-to-day experience with
Yes.
some of these things.
Yeah,
Because
our life depends on
yes,
this.
meaning that most of our lives they depends on engineering, they depends
Yes.
on technology, they
Yes.
depends on innovations.
Yes.
But because I always witness that with my niece. When she wants to tune in with the TV, I block her. She can change with the station, but because I have altered the line of sight
Yes,
between
yes.
the remote and with the TV.
The TV, yes.
Okay.
Yes.
Well, that one is really good. And from your perspective, what role will interdisciplinary collaboration play in pushing innovation forward in telecommunication and optics?
I've inevitably answered this question when I was talking about smartphones.
Smartphones, yes. And
Because
various
yes,
engineers
yes.
or scientists working on
So interdisciplinary research is the way to go.
that. Okay.
And let me be honest with you,
Yep.
that's one of the reasons why America is successful.
Yes. The collaboration of
Yes.
teamwork.
What I discovered on moving over here is the collaborations in the research. I'm going to give you a typical example. But what we have in Africa and the developing countries, and that's why those countries are still where they are, is because they believe that research is a competition.
Mm-hmm.
It is not. It's a collaboration.
And most of our researchers back home, they keep the research with manuscripts. They hide it from being published. Blah blah blah. You understand?
Yeah. So
like you struggle to get materials so further
exactly. So
add on what media.
what is evolving in the United States, and which other country needs to emulate is, you go to most research labs, you see people of this different discipline,
Yes.
different race,
Yep.
and different beliefs coming together to work on one problems.
Yes.
And what I found out is that has been very effective. Let me give you a typical example of interdisciplinary research my lab did. That was even before I joined them. There is this, they wanted to work on how to use laser light to kill cancer tumor.
Okay, with cancer tumor. Yep.
So someone from mechanical engineering and someone from biology, they came together, they injected a cancerous tumor in a mice. And so they now brought it to our lab for us to use a specific kind of laser at a specific power to shine it on that cancerous. And it was successful. They were able to do that. So now what is involved? Biology was involved.
Yes.
Physics was involved. And also electrical engineering laser was involved. So they were able to find out that if you're able to maintain this laser at a specific power, that you'll be able to, cure cancer with it. It didn't up to now they have not translated that research because it will have to go through a lot before it can be used in human.
Yes.
But the point is that different disciplines comes together, and they were able to get something useful done.
Okay.
If you go back to iPhone, for example,
Yes.
the guys that does material science, like determines the kind of glass, they are different
Yes, they are
than the
different.
people that design the lenses
Yep,
and the
definitely.
people that design the size,
Yes,
and also the heat dissipation.
yes,
The heat dissipation.
Yes.
Not even the heat,
the heat,
how you remove the heat
remove
from
the
the
heat
phones.
from the phone. Yep.
Because
Dissipation,
otherwise,
yep.
any of this will affect the functionality of the phone.
Yeah, definitely.
Somebody else determines the kind of battery you need to use and how well they discharge
Yes,
as you use them. So
definitely.
those are like different disciplines.
Different interdisciplinary collaboration.
Exactly. So for somebody that works on battery, will have a background in battery chemistry and all those kind of
Chemistry,
things. Somebody that works in the camera will have a background maybe in nonlinear optics or even linear optics,
Yes.
whatever the person works on. Then somebody that has to do with the glasses
Yes.
will have a background in material science. Not
Material
even
science.
only the glasses, the back, the cover and everything.
Yes,
All those
definitely.
things are well engineered to withstand. Do you know that after they have manufactured this phone, they had to do a test, drop it at some specific
Yes.
level to make sure that it doesn't crack, the screen
Yes.
doesn't crack.
Yes.
So test engineers are different.
Drop test.
Yes. So those are, so in everything you can think of, even in cars, for example,
Yep.
it's not the person expert in the design.
Yes. Yeah.
Somebody talks about the electronics of the car.
Yes.
Somebody talks about the engine.
Engine of the car.
Somebody designed the frame.
Yep.
So those are different experts. Those that does the upholstery of the car, they are different.
Yep.
Those that even determine the materials to use, they are different. So those are just to give you an idea of what an interdisciplinary research can do. It's really, really very, very helpful because some of the things you cannot think about as an engineer, a medical doctor, for example, can think about it. I have a friend that just graduated in electrical engineering. What she did in her research was to study MRI data, and she was able to connect that our brain is like electrical circuits. I don't know whether you have heard that.
Yes.
Our brains are made of neurons. In fact, that was where the concept of AI came from.
Definitely.
So our brains are in a combination of neurons, and something triggers it. So that was what she was looking at. In her team, she has a medical doctor. Meanwhile, she's an electrical engineer. So she runs the model. They will get real data of people.
Yes, of people
of
from
MRI.
maybe hospitals.
Yes, begin to specific diseases, trying to understand what is the difference. For example, between somebody that is normal and somebody that has a disease A.
Yep.
So by looking at the brain data, you should be able to have they call it biomarkers that differentiate normal brain from someone that is having. So just to give you an idea of what an interdisciplinary research can do.
That is really explainable. That it connects the dots between various industries that are working together to achieve a common goal.
Yes.
And I think that is what our African leaders need to learn from the field of engineering, the field of technologies, to deploy these strategies in most of our various institutions where we work collaboratively to achieve a common goal. So to close this session, I want you to give one key message to my listeners or my audience to take away about the future of connectivity and modern engineering. What will it be? Like one key message that you can share with my audience that they can go to bed with.
Okay, so for those that are at a place thinking about what to study,
yes,
I would say follow your heart. Do not struggle so much. Lean towards those classes, those courses that you can pass with least resistance. The reason I'm telling you this is if you go and, because you want to be a medical doctor, for example, and you now begin to study classes that you have to, struggle so much to achieve, then it becomes a problem. So for me, I've shared at the beginning about why I went into engineering. So just look at those classes that pique your interest and look around it and see which profession can I make out of this?
Yes.
Then for future of technology,
Yep.
what I will say to our audience is, the more we get connected,
Yeah.
the more careful we become.
Yep.
Because internet never forgets. Whatever you do will leave a footprint.
Yep.
And the more we get connected, the more we are, how will I put it? The more your location will be known.
Yes. Definitely.
So if you don't really want your footprint to be on internet, never use any phone. As long as you are using mobile phone,
A smart device.
a smart device, please note that you can be located anywhere in the world.
Anywhere in the world.
So be careful what you do and what you don't do on the internet. And I think that's, so as we become more connected, know
We become
that
more exposed.
no more privacy.
Privacy, lesser
Yes.
privacy.
Lesser privacy, because people can even hack into your phone.
Yes.
And now we are talking about smart home. People can hack into your home
Yes, definitely.
and collect data. So the more we talk about getting connected, the more scarier it becomes. Because the technology is moving faster than the regulation.
Yes.
I don't know whether you've talked about policies.
Policies,
Yeah.
yes. At some point, I will have to invite
Yes.
one of my
So the
my
challenge
guests
with
to come and talk about the policies.
the challenge with evolving technology is that the technology is faster than the policies of government or the control to maintain those technologies. I don't know if you've had the class project. I think 2 students from MIT did. Have you heard about the smart glasses?
Yes.
Yeah.
the
So
smart
that's
glasses.
scary. So what their project was, if you have a LinkedIn account, without that smart glass, when they look at you with facial recognition, they will tell you your name.
Yes.
They will tell you your profession, even though they are meeting you for the first
Meeting
time.
you for the first time.
So how scary can that be?
Yes, definitely.
I don't know how ethical it is, but at least that gives you an insight
Yes.
of what the future will be like,
Yep.
where you will not have secrets.
Yep. I think even with the Meta, they are releasing their new with the model and design of maybe their AI with the glasses that can even communicate, that can even help you to even work remotely, just looking through your glasses, you can communicate with someone elsewhere. So I think that message is clear. The more we get connected, the more exposed we become towards basically with the bad actors, and that is why the field of cyber security, it is going to go big, but because we need cybersecurity engineers to help us control these bad actors, and every day we have form of good actors, some of bad actors. So
Yeah, so just to support what you're saying, but also I need to put out a caveat. Cybersecurity is good, it will protect us to some extent.
yes,
But the best protection is you and me.
Yeah.
Controlling what we do or we
and
do
what
not
we
do
yeah,
on
sure.
internet. You can control the kind of pictures you post,
You
even
post.
on your personal
Yeah.
on your personal folder like Google Photos.
Yeah, Google Photos.
Yeah, you really need to control the stuff you put on internet, because when you might not be hacked, but as far as those things are on internet, one day it might get exposed.
Yes, it might
so
get
whatever
exposed.
you don't want anyone to see, don't ever put it on
Don't
internet.
ever put it on the internet. So, but guys, I want to thank you all for listening in with today's episode of Engineering Trends and Innovation, where we explore the cutting edge of engineering and technologies that are shaping our future. As always, we are here to bring you groundbreaking engineering trends and innovation that are creating impacts in our daily lives, and also how we can connect our day-to-day activities with engineering and innovation and technology. So thank you very much. I am your host, Alimami Conte, and please stay safe, stay glued for our next episode, and don't forget to subscribe, like, and share this episode to friends and families. Thank you very much.